Today in the Physics Funhouse, we are going to attempt to understand sinusoidal curves. Now, I am not a pre-calculus teacher, so you are not going to understand everything about sinusoidal curves and how to transform them and shift them. Basically, what we're going to work on today is filling in the blanks to the basic equation y, or position, equals a sine 2 pi f times t. So let's talk about what all these different things mean. A is for amplitude, that is the maximum displacement from equilibrium for a simple harmonic oscillator or a wave. The F stands for frequency, so the number of waves per second. You can also think of that as being 2 pi over the period, but introducing a fraction, all this is just going to make it even more complicated. And then the sine part basically tells us where to start on the graph. And so, and t, of course, is our time variable, which would be our x-axis variable. And so if we can look this up on our AP Physics formula chart or remember it, basically it becomes a game of fill in the blanks. In order to really understand what's happening here, what I recommend that you do is spend a little bit of time playing around with a graphing calculator, like Desmos. And so what I've got over here is a programmed an equation, y equals a sine 2 pi ft. And I've chosen only positive values for time. So time greater than or equal to 0, because we don't have negative times in physics. And I've set on there 2 sliders. And what you'll notice, let's kind of zoom this out a little bit. When I take the A slider, so that's out in front of the sine, and I start sliding that around, notice that the shape of the wave-looking graph gets bigger, but it doesn't change how far apart the peaks and the troughs are from each other. And so, get our scale back over here. So notice that when I set it to 2, notice that the graph goes up to a maximum value of 2 and a negative value, excuse me, a minimum value of negative 2. If I slide that further over up to 3, now notice the graph just goes up to 3, but it doesn't change how far apart those peaks are. So I can put it up at 4, and the graph goes from positive 4 to negative 4, so an amplitude of 4. Let's dial that back a little bit. Notice that when I move around the frequency slider, that's going to make the peaks and troughs be further apart. And so if I slide this to the right and increase the frequency, notice that the waves and troughs, excuse me, the peaks and troughs get closer together. And so this is a frequency of about 6. And then, let's not do negative frequencies. Here's a frequency of 0.4. So notice 0.4, there's a lot of time between each peak and each trough. At a high frequency, there's very little time. So let's kind of zoom this in and let's do a little bit of counting here. I'm going to dial this back down to 1. Okay, so with a frequency of 1, notice that we get 1 wave, or 1 oscillation in 1 second. Now, when you write the equation, like on a piece of paper, typically you wouldn't write a 2 and then a pi and then another number for the frequency. And so typically how we would write this particular equation with the frequency of 2, we would write y equals, so in this example my amplitude was 2, and since we're physics students, let's give that a unit, maybe 2 centimeters. Sine 2 pi and then 2 hertz was the frequency times t. So typically what we will do is combine those 2 in there. A lot of 2's for one equation. So instead of writing 2 pi times 2, we would write 4 pi. And if you neglected the unit, that would be okay, because 1 over seconds times seconds would just give you nothing. And so your equation would end up looking like this. And so if you see an equation and you're asked to figure out the amplitude and the frequency from the equation, well, the amplitude is easy. That's just that part there. The frequency, look at this number inside the parentheses, and remember that you have to take out the 2 pi. And so 2 pi times 2 would give you the 4 pi that actually shows up in the equation. So that's kind of one thing that's a little bit tricky if you're asked to interpret an equation. Remember that it's a 2 pi times the frequency inside that parentheses. Okay, so what does the sine little bit tell us? The sine bit essentially tells us where to start. And so if you look back here at our graph, you'll notice that the graph goes through the origin. It goes through 0 at a time of 0 seconds. If I were to change it from sine to cosine, let's do that real quick. By changing it to cosine, you'll notice that the amplitude didn't change. It still goes up to 2 and down to -2. If you look carefully, I still have a frequency of 2. Started at a crest, 1, 2 waves or oscillations in that 1 second. The difference now is that instead of starting at 0, it starts at a maximum. And so a sine graph starts at 0, 0. A cosine graph starts at a maximum. If I were to have a negative cosine graph, like if the amplitude were to be -2, that just starts at a negative maxima. If you want to call that a minimum, I guess that would be okay. And so a negative cosine graph would start at -2, whereas a positive cosine graph, positive number, would start at +2. So what about a negative sine? So let's make this back to a sine graph. So notice again when I put it back to sine that it starts at 0 again. If I make it negative sine, notice that instead of going up originally like it did before, it goes down originally. So basically what the sine and the cosine tells you is what are the starting conditions. Where does it start, or in what direction is the first oscillation? So positive, you'd either start at positive or go up to begin with. Negative would either start below 0 or go down to begin with. And if you can remember, sine starts at the origin, cosine starts at a maximum, then you know everything you need to know for Physics 1 to interpret a graph that looks something like this. So let's look at an example together of a graph created by a simple harmonic oscillator and see if we can extract the exact equation of motion for that simple harmonic oscillator from the graph. And so our starting point is still y equals a sine, parentheses 2 pi f times t, and what we need to do is just fill in the blanks and then simplify as needed. So the first thing we might do is figure out if it is a sine, cosine, negative sine, or negative cosine graph. And so looking at my starting position, it starts at a maximum or minimum, so that means cosine. And since it starts at a negative maxima or minimum if you want, then we know it is a negative cosine graph. So even though on the equation sheet, remember this about all formulas on the AP equation sheet, if it says sine, that doesn't necessarily mean it has to be sine. It could also be cosine, and we need to know the difference. So I know that this is going to be a negative cosine graph because it starts down here at a negative maxima or minimum, whatever you want to say. Next, let's figure out the amplitude. Here is equilibrium right here, 1 unit above equilibrium. So this distance right here would be my amplitude, and that's a distance of 1 centimeter, or whatever unit we're after here. And so let's just use centimeters. So A is 1 centimeter right here. And then the last thing we need to do is figure out what is the frequency. So the frequency would be the number of oscillations that occur in 1 second. And so here's 1 second way over here. And so starting at a negative position of -1, negative minimum, negative maximum, whatever you want to say. So we make 1 oscillation, and then a second oscillation, up and then down, a third oscillation, up and then back down. So there is a 4th oscillation. So in 1 second, we make 4 oscillations, So that is a frequency of 4 hertz. So now all we got to do is just plug into the equation and then simplify as needed. And so that might look like y equals the negative cosine graph. So I'm going to go ahead and put the negative sign out front. And then 1 centimeters was our amplitude. And again, we know it is cosine. Cosine 2 times pi. The frequency is 4. And then our x variable, just call it t, and so it would look something like that. And so the only thing that we might need to do after that is just kind of combine the terms inside the parentheses. And so that would look something like y equals negative 1 centimeter cosine 2 times 4 is 8. Don't forget the pi. And then don't forget the x variable t, like that. Okay, if you wanted to, we could go ahead and check ourselves by graphing it again and seeing if the graph we get using a graphing calculator looks something like that. Okay, so pulling up a blank graph in Desmos, I'm just going to type in the equation we got over here. So y equals negative 1 cosine 8 pi, and then times t, close parentheses. And so there's the graph that the graphing calculator gives us when we type it in. And let's just kind of check its features. First of all, it starts at a negative maxima, negative 1, just like that graph starts at negative 1. It goes up to positive 1 and back down to negative 1, so the amplitude is 1, just like we said. And then if we count the number of cycles between 0 and 1 second, there's 1 cycle, 2 cycles, 3 cycles, 4 cycles. And so the equation we derived over here, when we graph it in the graphing calculator, it gives us back the graph that we were looking at. And so it shows up every now and then as like a multiple choice question. Here's the graph, position versus time for a simple harmonic oscillator, and then it's like a match, one of the 4 equations. You can always check yourself on these kind of things if you have a graphing calculator by just graphing that and then seeing if the graph generated by the calculator matches the graph that you got when you went through these steps here. And so that's definitely something that you can check your work on if you kind of take a few seconds to do it. A stands for amplitude, that goes out front. That needs to have a unit because your y value should also have a unit. So if the y-axis is in centimeters, your amplitude should be in centimeters. The sine or cosine bit tells you where the graph starts. If it starts at origin, it's a sine graph. If it starts at a maximum, it is a cosine graph. If it starts at a negative maximum, it's a negative cosine graph. The 2 pi's because we are working from radians here. F for frequency, and then t is our x variable, our time variable. And so the things in yellow will always be the same. The colored things are the things that you need to pick apart from the graph. That equation is on your AP physics formula chart. What isn't on there is the meaning of all those things in there. So we need to just know how to find the amplitude from a graph, the frequency from a graph, and then if it is a sine or cosine function. We'll be sure to do plenty of examples in class. Till then, ta-ta.